All right, here we go. Derivatives. This is really what this chapter is all about. Derivatives is a fancy way of saying finding slope. We are going to be changing values of x and looking at the change of y or f of x as a result. From that, we're going to be able to find the slope using the exact same formula we used before. We call that f prime of x. That is a prime symbol. F prime of x is the derivative of f of x. And so this is the limit as x approaches 0 of, and now we're going to get away from the c thing and just go with it in terms of x. So this is going to be a function of x plus delta x minus the function of x over delta x if the limit exists. No goofy vertical lines, please. Thank you very much. So that's what this is all about. It's exactly the same thing, only we slightly variated the verbiage for our variable. Instead of c, we're using x, which makes a lot more sense, because that's pretty much what we're talking about anyway. But the c emphasized the infinitesimal difference is what we're looking at here. Okay? This process that we're going to define derivatives is called differentiation. That is the process of finding derivatives. So, what we're going to be spending some time on now is doing a whole bunch of derivative work. Your book is a definition there, where a function is differentiable at x if the derivative exists at x, and that's what this is saying right here. And it's differentiable on any open interval AB if it is differentiable at every point between A and B. So this is kind of like the calculus bookkeeping to make sure everybody understands that there are a certain amount of limits to it, and the limit is basically, if you pardon the pun, if a limit exists. Okay? Now, there's a number of ways that we can express this in a shorthand form. F prime of x is certainly one of them. We also use this, which we call dy dx, or we also say that that is the derivative of y with respect to x. So you hear these terms a lot, but it means the same thing. You also see y prime as a way of describing f prime of x and dy dx, or d dx of f of x. That's another one. Now the next one I haven't really seen a whole lot, but I'll bet you anything it's European. Capital D sub x of y. I have never seen this, but it has been a while since I've taken calculus, so maybe this is a rather new thing. Don't particularly care for it. I like this one right here. I've seen a lot. This one and this one. To a certain extent, this, particularly when we're doing semi-proofs involving calculus, we'll use this a lot as well. But these are the main ones here. That's just goofy. Let's make it capital D and make it look really important. Well, it's important. You don't need to put a capital on it to do that. All right. So, there's something called the limit process, and that's pretty much what we're doing right now. That whole thing that we were doing previously is basically the limit process. We go through the limits, and then we're able to figure out the slope from that. So let's suppose that we have the function of x is equal to x cubed plus 2x. So we're going to do this one more time, and we've done this already a couple times, but it's worth doing one more time to make sure we get really familiar with this. So that means the limit as delta x approaches 0, and I'm going to put the definition up there one more time just to make sure we got it down. F of x plus delta x minus f of x over delta x. That's the differentiation process. So again, x plus delta x is going to go in for both x's here, and then we'll leave the x's alone there for this, and then go through our mathematical manipulations. So let's do that, shall we? So x plus delta x becomes x plus delta x quantity cubed plus, so that went in there, this is going to go in right here, 2 times x plus delta x. So that's the first part of that numerator. The second part is just, since we've left x as it is, we're going to use just x cubed plus 2x. So, but make sure you put it in parentheses, x cubed plus 2x, because the entire expression is going to be subtracted from this thing right here over delta x. We're doing big boy math now, but it's not that big boy because this is stuff that you should have done before. So the more you do this, the better you're going to be as far as being mathematicians. Pascal's triangle, 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. This 3 tells you that this is what we're going to be using for that. So again, remember, we're going to start off with x cubed, and then x squared, and then x, and then no x. And then the same thing with the delta x. There'll be no delta x here, delta x squared, delta x cubed here. So this becomes then x cubed plus, and this coefficient goes in right here, 3x squared, and then the delta x gets introduced for the first time, plus, now 3 is the next coefficient, 3 times x, so the x squared becomes x, but now the delta x becomes delta x squared. Then 1, so plus, and that is going to be no x over here, because now that's a 0 exponent, which is, it drops it out. But now we have quantity delta x close quantity cubed. That's that entire monstrosity right there. Minus, now we change the signs here, x cubed minus 2x all over delta x. Yikes! Look at that stuff! All kinds of stuff! But what's really nice about this stuff is that we can cancel some stuff out and then use the delta x to get rid of even more stuff. We like getting rid of stuff. So, x cubed, negative x cubed, get out of here. Get that. Then we got negative 2x. Well, that's interesting. What did I forget? Did I forget something? I did forget something. I forgot to do this part right here. So let's wedge that in right here. Plus 2x plus 2 delta x for this part right here that I forgot. Again, thinking ahead and not realizing that I'm not concentrating like I should. A danger. So danger, danger. So x cubed cancels out and negative 2x cancels out with the positive 2x. So that leaves us 2 delta x right there. Okay. Now, so I'm going to factor out a delta x out of everything. So I got 3x squared plus 3x delta x plus delta x squared, quantity squared, as I factor out the delta x out of all of that nonsense. Oh, and plus, I almost did it again, plus the 2x, 2 delta x rather, so that's plus 2x over here, and delta x goes in front right there, all over delta x. So I factored out the delta x out of each of these right here, these 4 terms. So that cancels that delta x out, and now I can go with the limit as delta x approaches 0. So every time I got a delta x, that's going to eliminate that term. So that's going to leave me 3x squared plus 2x is equal f prime of x, or my slope. But the point here is Well, what is the point? Did I put it in there? No, but it just want it in terms of that. So that is the equation for the slope at any particular point on the curve, given the value of x, and just plug that in. Okay? So keep that in mind, and then do your practice problems. Page 104, 12 through 24E. So 7 problems to warm up your mathematical skills. Good luck.